What was that? What did just give me some magic clocks.
Magic clocks.
You want to do that, Tim?
Sure.
Okay.
Alright, magic clocks was a nice little problem. I'm pretty sure was written by Chip.
It was.
So basically what you're trying to do is if the hour hand, if the angle between the hour hand, the mid hand, and the second hand are all equal, then it's a magic time. And so you're trying to find all of the magic times in the day. And you're given a sample input that gives you a time, and you need to find the nearest magic time to the time that they give you. And the problem specifies that the magic time will be within 1 minute, so you know it's not going to be more than 59 seconds away. And at first we were kind of thinking it was going to be some very tricky stuff that we could do, but we kind of decided it would be fun if we just thought about the clock linearly, like as a number line, and if the distance between the 2 pointers on a 0 to 60 scale are equal, then, or the distances are equal for all the cases, then it's a magic time. You can just move those pointers through that array, pre-build your list, and then it will be as simple as a table lookup. I can't remember if we actually sat down and started writing it or not. I think we had the algorithm on paper, but we never had time to sit down. But in theory, it works.
And that's all that counts.
So we got theoretical points.
Yes, and those are the most important ones. Curve killer. Was that?
Yeah, that was the other one.
That problem set.
Oh yeah, here's the problem that Chip also wrote. We guessed that Chip wrote the problem because they refer to people with
You think
similar
Chip wrote
names.
magic clocks?
What?
You think Chip wrote magic
Well,
clocks?
the first name of the protagonist in that story is very similar to one of our.
Well, Mickey Mouse gives it away too.
Yeah, it does.
Well, I mean, everyone loves it. It's really hard to say. But, yeah.
And I mean, curve killer is kind of the same. It's about assembling class where nobody gets a good grade. So
Chances are.
Such a coincidence.
If you want to, yeah.
Well, like you said, Chip wrote this problem. This was my personal favorite problem of the second side. Teams A and B at small college, we had the same basic algorithm for this problem. Neither of us actually about it. But talking to Chip afterwards, we were headed in the right direction. Basically, what they do for this problem, you're given a distribution of grades. They just give you the numbers. See how they 75 times
Or
lower numbers. Oh well. Okay. What they give you a distribution of grades, and then they say modify these grades so that the mean or average of the grades is changed to a specified value, and the standard deviation of the grades is changed to a specified value. All right. So you can see they give you the formulas for finding the average and finding the standard deviation. What we found was changing the average of a distribution is not all that hard. You can actually just add the difference to every single value. For instance, if you've got an average of 50, you add 10 to everything. The 10 kind of just factors its way out, and you end up with an average of 60. The problem comes when you're trying to change the standard deviation. Because as you can see, that formula is much more complex. Tim and I were talking about this problem. We realized we were going to have to shift the difference between the average and the numbers by some value. We weren't sure if it was the same where all the numbers are different. After banging your head against that for a while, I have what you might call a bathroom epiphany. And I realized that if we shift all of the grades so that their average is 0, then changing the standard deviation is a lot easier. And after doing that, we actually realized you just have to multiply by a constant. So in the end, the problem actually has a reasonably simple and elegant solution. Sadly, neither of our teams successfully did.
Are you convinced this has a unique solution?
I mean, if you only have 3 data points, that's one thing, but if you've got 20 data points.
Oh.
Yeah, I'm not convinced of that. The way that I was looking at it, if you don't shift the data, what happens is you end up with n number of coefficients and only one equation to solve, which means that there are lots and lots of solutions and we're really difficult to.
But I would think you could take the 2 endpoints and move them further and further out to get the standard deviation, or further in to change the standard deviation.
Yes, but well, sort of. It changes the grades in a somewhat unpredictable way if you do that. And so.
Well, not if you move them equal amounts. You keep the average. And so, you know, if you want the standard deviation to go out, you make one lower, one higher. You want the standard deviation to come in, you make, you know, you move them in. I'm far. Thank you. You're a math major. You should know this better than I do.
It wouldn't. I think it would be a correct solution to the problem. I don't think it would counter correct.
I mean, and you can't tell
Would
because
be a
the
good way
only
to correct
samples you
correction.
have are 3 data points.
Yeah, I mean, I'm not suggesting Dr. Allen should do this, not do curve grades, but
I might try it out on my web class.
We're in that. Okay. Yeah. Right. Lottery. I guess that's you're
Okay.
you were
All right. This is just a little lottery problem where someone has pulled out a bunch of numbers on lottery balls, and they pick the winning numbers is the set with the lowest maximum difference. You want the least maximum difference. And it was actually, I was reading through the problem, and it's almost like they handed you the algorithm in the problem description, and it's kind of right here. And it's where they sorted all of the numbers from smallest to greatest, and you go through, and in each set you have N and M. N is the number of colors, and M is the number of each color that you have. So you'll have 3 colors and maybe 4 of each color. Well, each set only has 1 of each color. So you sort them by value, and then go through and you grab the smallest one, the very first one on the list, then you grab the next smallest one of a different color and the next smallest one of a different color, and you check the value. Then you drop the first item on the list and keep going until you run out of either, until the rest of your list has less than your number of colors or is too small to hold the maximum of the chain of numbers. We actually had this solution within about 2 lines of being finished. We hadn't actually run it yet. We were still typing it up when our other pair came in the room yelling that they had figured something out on, I think it was problem 6, the curve killer. They had thought they had come up with a solution, and we only had about 5 minutes left, and since we hadn't been able to test our program at all, we decided to let them go ahead and finish working out theirs. The next day, I typed up the program. We printed it out. I typed it back in using Notepad++, moved it over to Cobra, ran it, took out a line, put another line in, and it worked. It took me about 45 seconds. So this is one of those things that go with strategy as far as time management and knowing when to, yes, hold them and hold them. It was something you really can't say. I mean, we didn't know it would work. So we were passing to people who had already been working on a problem and were pretty sure they had a solution.
The problem we were having is our algorithm was, we thought was fine. The only thing we were having is we basically had we knew the problem was division by 0 somewhere in our code, and we found that. And we jumped on it because we figured that was our big problem. And there was just a little, there was one line we probably needed to switch. It was very close though. However, yes, we probably should have let them stay on Yes, Mr. Kirk.
Travis, do you have any? I mean, what size of inputs did you run this on? Like when you ran it?
Oh, I gave it to Dr. Dyer and
Okay.
the judge did.
Yeah, that one's on. Let's see. Discussion. Oh, this is okay. Well, I'm gonna do this one for. I have the most positive spin on it. The 2 submits for word count. Let's go to that one. We did get it.
This was actually the second one we sat down to code. We just passed it off because of some issues.
This problem is actually very simple. You basically have a input, a series of lines of input, and you count the number of lines, the number of words, the number of bytes. I believe Tim, Tim and Travis wrote this, and they were having an issue with when they would run it. As you can see, the lines down here. There's 5 lines, and you can assume there's 40 words, and that's how many bytes there are. And for some reason, the words and bytes were working, but the lines was only 1. And the way we were setting up, we just would paste in the input, and that would come up. So they took a break from it to try to figure out why the lines weren't anything. So clearly it was something very simple. So that's when Steve and I jumped back down and did Josephus and word count, and they jumped back on. They just couldn't figure it out because, I mean, it was Python, so it's really easy to tell where certain things are. They just couldn't find anything. So then Travis and Steven started working on something. I sat down with Tim to help try to figure this out. And I tried just typing in the input like on the keyboard, and it worked. Like it got all the lines. I'm like, oh, well that's weird. Okay, well let's just send it then. And so we sent it, and it was wrong. We're like, oh, that's most unfortunate. So we left that one alone, and we started asking questions and said, we're having this problem where if we paste it in, it works, and if it doesn't, it doesn't. You know, and we've been kind of back and forth trying to figure out what the problem was, and after about an hour or so, we figured out or they gave us a way to do it correctly, and then it was right. So, the problem was with while not in the file count. No, it was with idle. Idle. No, I mean like problems that had like keep going until.
Yeah, it was the way that idle takes in input and the way that the judging data was set up. Idle didn't like how the new lines were set up, so it was just kind of a confusion thing that we should have caught.
Right.
But if we had gone over that during our testing period, before every competition you have, a few hours to sit down and do some practice problems and to test your environments, and this is just something that we didn't test in our environment. And so it's kind of a surprise for everybody why it wasn't.
And you pass notes on to the members of the team who will be there next year?
The reason we didn't test it, the 3-hour thing, is we had just gotten in from the 6-hour drive, and we had problems getting Java, C++, and Python kind of working because we wanted to use Notepad++ as our coding style, and so we had to get that installed, and then like we never used, or at least I never used DOS before, because that's how you basically ran them. So we were getting used to that, and it was a little bit of an ordeal getting all that working. So we just assumed, oh well, Python's fine. It's so nice. It'll be good. And no, it didn't. So there was a little hitch in the way that we were supposed to set it up, but I feel that Team B found it during the practice session. They didn't. They were nice enough to tell us about it, but but they found it. So that means that it was easy to find. So oh no, I didn't mean it like that. I meant like from testing you would have found it. It came out. Anyway, it means that you could find it through the sample, the test time they gave it to us. So we would have probably found that, and then we would have told them about this hitch. They would have given us the proper way to do it, and we wouldn't waste an hour trying to figure out what was going on with our code. Because basically the rest of the solutions besides the 4 we solved all would have had this problem. So even if we coded them, it was like...
we were kind of holding off on some of the problems we knew we could solve because we weren't sure what the issue was.
Right. And some of the responses were like no response. So we're like, oh, it's probably, the way our code's set up. And we would go through the code again to make sure to see if there was like something we were doing really dumb in the code. Instead of just sitting there going, oh, it's a system.
Instead of no response, the judges were taking time to find out what the exact problem was, and then they sent a general memo out to every team about what the problem was.
Yes. So, I mean, it was an unfortunate thing to happen. It wasn't really anyone's, well, I guess it was more our, I don't know.
We should have found it. So, I think another thing that, I don't know, it got me pretty heavily. I think some of the other